Got something new from Polymaker in their Fiberon line. What is it? Well, let's break some stuff first, and then we'll talk about what it is. Stick around. Hey everyone, welcome back. I'm Scott, Edge of 3D. You know that already. Clicked on my channel. So, what do we have? Well, we have a new filament from Polymaker in their Fiberon line, and it's PET-GF15, which is polyethylene tetrafilate. I'm going to butcher that as best I can. It's got 15% glass fiber content in it. That's what it is. So, why? Okay, the question is why. Polymaker has a PET that's a carbon fiber. It's PET-CF15, I believe. I may be wrong on the percentage, but it's a carbon fiber filled or carbon fiber filament with carbon fiber in it. This is filament with glass fiber in it. And why do we need one or the other? Well, one of the big complaints of the carbon fiber filled, the PET-CF, is delamination, brittle, several things like that. And Polymaker's pitch deck that they sent out to us on this, that's one of the things that they looked at was all of the reviews online of the materials, and there was a lot of people that weren't happy with the PET CF17 for layer adhesion and delamination, so on and so forth. So enter PET glass fiber 15. Now, one of the things that I really like about this right off the bat is in a lot of the Fiberon line, you have a choice of, let's just call it Henry Ford. You can have it in any color you want as long as it's black. Well, you can have this in any color you want as long as it's one of these 6 colors. So you have your black, then you have white, you have a dark gray, a light gray, a red, and they call it just blue. I'm going to call it baby blue because it does kind of have a baby blue color. So right off the bat, when this launches right now, you can order any one of these 6 colors. And as you'll see, I'll hold the black up here. That's the top surface. This is the bottom surface. Now on these carabiners, you know, you have these little extra pieces that you print, so I kind of mixed and matched colors on these, but it has a very muted, it's not glossy, and it's not a really matte. It's kind of in between. I think they call that a satin, maybe. So it's not shiny and it's not dull. It's somewhere in between. I really like it. Really like all of the colors. I'm not a huge fan of the blue. I would have liked it to be a little bit more blue, but you know, hey, teach their own. Now, I ran this through all the normal tests that I ran all the materials through. I have not done any test with it in the annealed state yet. That's coming right now. They sent me all 6 colors. I just ran the black through there. I've already done a video. I'll pop a link up here where I compare differences in colors. Not in PET, but I do it in some other materials, but you'll see. So ran it through all the normal tests, and we'll get into that in just a minute. And then, of course, I printed out these carabiners, which I love these things. I print these out in almost any of the engineering grade materials that I get. I print these carabiners. I give them away, and then I also use them for my water bottles that hook to my backpack when I travel, and I travel a lot. This is material is aimed at that sort of stuff, some functional stuff. I wouldn't go rock climbing with these unless you're, 20 pounds or you just don't care. But my big extra large person. I don't think I'd trust my life hanging on these, but I've not tested this either to see how strong these are. Who knows? It may hold up. So, um, I haven't printed out anything else with it yet functional. I am working on designing a cage for my underwater camera. Early next year, I'm leaving on a trip and I'm going to the Middle East and the Indian Ocean for 2 weeks to do some diving and snorkeling and stuff. So, I've always had my camera, and it's got the floaty thing here that stays attached to it and all that. But I'm going to try to print out a cage, a camera cage, and I'll pop some pictures up here. There's some DSLR cages and stuff out there, but I'm designing my own cage for this Olympus. This is my I've had this camera for like 10 years maybe. It's an Olympus TG4. It works great for underwater pictures. You'd be surprised. I might throw a couple of those up there too from the last time I was Hawaii or Maldives or somewhere diving with it. But I'm going to try that. I'm gonna print a cage for this and see how this stuff holds up in salt water. But this is October the 14th. I leave February 23rd to head for Dubai, so you're going to have to wait a while on that. That's going to be a long-term report to check back on. So let's jump over to the materials chart first, and I'll show you where this stacks up compared to everything else. And while we jump onto the chart, the other day somebody posted a question on the let me jump back here. Somebody posted a question asking, has my chart changed? Has my web page changed? And my response to them is, it's a work in progress. And I'm constantly updating it and adding to it and playing around with it and saying, well, I prefer this and I prefer that. And I'm not a code writer, so I do the best I can. And so that's where we're at with this chart. Is it's a work in progress. It's the best I can. So this is the landing page. When you land on it, I don't think it's going to be sorted by value. I think it's going to come up sorted by name. But I've added these buttons here where you can sort by name, sort by value, and you can go descending, ascending. And then this right here is if you want to print this out, you can print it as a PNG or a JPG. But this is just the chart view, and this is everything. So if you want to just see what the strongest x-axis, which is the shear test, that's right here, this one, that right there. The piece is 5 millimeters by 10 millimeters. It's printed all walls. It's solid. I break it. That's the shear test x-axis. PPA core by Tech. See the video on that? 400, 500 kilograms of force. So, the strongest layer adhesion, PPA by Tech. Direct thread yield, again, PPA. What you get the point at this point. Let's just do Polymaker. The glass fiber filled is 22103. The PET-CF, and I don't have the number 17 on there, but it's 17% carbon fiber. So the glass fiber is stronger in the x-axis. Now the yield point, that's how far it stretches, where it peaks out at, and then most of this material will peak out and then it will stretch a little bit further and break. Here's showing you from start to finish. This is the part loaded in. I started at I preload it to 5 kilograms of force, and then I zero everything out. I start the test. That way the pulls are all even, and it starts from 5 kilograms. It pulls till it breaks. And you'll see right here, this is a full test. This is from 5 kilograms preload all the way to the point of break. So what you get here is you get a point where it peaks out, and in the case of the glass fiber 15 on the chart here, 3.34 kilograms, that's where it peaked. And then it went ahead and went on to 3.34 millimeters, not kilograms. And then it stretched on to a point of 4.22 millimeters before it broke. Now, if you look, 3.29 and 3.34, we're talking about 0.15 millimeters. Not even a measurable amount. And then with the break point, 4.22 to 4.23, 1/100th of a millimeter. Now, here's where things start to get impressive with this material. Layer adhesion. One of the complaints on the PET carbon fiber is delamination / layer adhesion. And as you can see right here, 87.66 kilograms of force on the carbon fiber, 134.2 kilograms of force on the PET glass fiber 15. Let's go ahead and pop a Ceratec unannealed in here. And you can see that it beat the Ceratec as well. The Ceratec carbon fiber, about the same as the Polymaker carbon fiber. Now I will test some more Ceratec. I have some Ceratec PET glass fiber that I will be testing at a later date. The next one is direct thread yield, and that's a 3mm screw screwed into a 2.6mm printed hole, 4mm deep, and this is how many kilograms of force till it failed. 69.73 kilograms. That is a very respectable number for a 3mm screw screwed in 4mm into this plastic. You can see the glass fiber compared to the carbon fiber, close to double. Heat set yield. They get a little closer here, but same thing. It's a 4mm deep, 3mm heat set that's use a heat gun to insert it into the part and then pull it back out. 130 kilograms of force. Again, a very respectable number. And finally, the IZOD shock test. That's the thing over my left shoulder here on the screen, that funky looking red and black machine. It's the hammer. See right here, it's the hammer. It breaks the part, and it measures how far it swings after it hits the part. A value of 100 would be a dead stop. That would stop the hammer when it hits the part. Haven't found a material that stops that hammer yet. Had some come close, but I haven't had anything stop it yet. But 25.67 for the glass fiber, 23.5 for the carbon fiber, and any of your filled materials are going to have a lower number. It's just you're adding stuff to the fiber. It gives it a place to break. Let's just throw a PLA in here, for example, and let's see, we'll do a PA6, co-PA, and let's throw an ABS, a black ABS in here. And this just gives you kind of an idea. So the PET glass fiber, 25.67, and then you start going through these other materials where they don't have any additives, 27, 33, 38, ABS being the strongest at 58.4. So there you go. That's a brief rundown. That's the numbers. First set of tests. I will be printing more parts. I will be doing heat tests. I will do some of these tests right here. Let me see if I can get this out here without knocking everything over. Where I print the parts, I anneal some of them and I leave others unannealed. I heat it with 50 grams of weight and see where it fails at. So that test is coming. The test where it just one's annealed and not annealed and they just under their own weight and see how far. Again, those tests are coming. I haven't got to that yet. All takes time. So price-wise, let me get the latest because I know they just updated the price this morning. I had a price on it originally, and then this morning they updated the price. $29.99 per kilogram, so $30 for a 1 kilogram roll. So it's not a cheap filament, but it's not an expensive filament. It's middle of the road. It's not a low-end filament, and I hesitate to use the words low-end when I'm talking about PLA because PLA is still my favorite, and PLA does a lot. That's a PLA Voron 0 right there. Video that somewhere. Also a Polymaker filament. That was the launch on the high temp PLA. I made a Voron V0 printer. It's still printing. It's turned around right now because I have a Wi-Fi issue on it and I'm changing out the little Wi-Fi dongle. So PET glass fiber 15, $30, $29.99, $30 roll. Link in the video description down below, right here. You can click on my link and buy it. You can buy it direct, however you want to do it. Doesn't cost you any more to use my link. I get a little tiny kickback. And Polymaker does monetarily sponsor my channel as well. They give me a budget each month to spend on buying filament and testing and stuff like that. If you want to support the channel, down below, you can buy me a coffee as well. I'll keep doing these videos. As always, my chart of all my tests are free. It's not hidden behind a paywall. You don't have to pay me a monthly Patreon or anything like that to access it. If you found this video, click on the link. You'll find the chart. So there you go. Polymaker PET, and I'm gonna butcher this again. Polyethylene, I can get that part right. And then the TEREPHTHALATE. So terephthalate. PHTH together. I have no idea. Somebody smarter than me can look it up in a dictionary and get you the description. Lot of I have the full TDS technical data sheet. In fact, let's jump over here right quick, and I will share that, and then I'll put a link to this as well in the video description. So this is the technical data sheet that Fiberon or Polymaker puts out, and basically goes over the physical properties, thermal properties, all the mechanical properties, and they do scientific testing. I do TLAR testing, which is that looks about right. So their stuff is scientific. My stuff is, you've seen it. I like breaking crap. Let's break stuff. I did print this, my test. I did it at, I did a first layer at 310 and then printed everything else at 300 degrees, 80 degrees build plate. I did run the chamber on my CD4 Plus at 65 degrees. It does say room temperature here, but I went ahead and ran it at 65 degrees. I don't know whether that hurts or helps or whatever. I have not done any annealing. 120 degrees for 16 hours. That's a long time to anneal. I will get to all that. I will do annealed tests. And then this just goes through some notes on there. This tells you how to make the specimens that they use to test. And I did use some of these. You'll look, my stuff is kind of similar to this, but I have my own way. And then here's a materials comparison chart. And I really like this. Right here's the PET glass fiber 15. This is where it comes in the bending modulus versus the heat deflection. And you'll see it's kind of in the middle of the bunch. You get way out here on the extreme edges. You've got PPS carbon fiber, PPS glass fiber, which I've not tested the PPS glass fiber yet. You've got PA6 way up here on the bending modulus. I have tested the PA6. I'm currently testing PA12. So there you go. A link to, I'll upload that to my Google Docs. I'll put a link to it. You can download the PDF off my Google Docs and take a look at this for yourself until they get it up on their website. Once their website's fully up and running, this same information will be available there. But right now, I don't have a link to theirs, so I'll give you a link to mine, and then you can have mine. And hopefully, unlike the high temp PLA launch, they have their website ready at the same time this is launching, not like the PLA where my video came out 4 hours before their website was updated. So if this is anything like the high temp PLA, if you want it, get it now. Otherwise, you're going to be waiting on the next boat. So that's it for now. More testing to come. Like I said, I'm just finished breaking an entire box full of PA12. And that stuff was actually printed several months ago, well, 3 months ago. But I wanted to let it acclimate to current conditions. So not in a dried state, not in a freshly painted state, not in an annealed state. I annealed half the specimens, didn't anneal the other half. I've left them set out in the open for the last 3 months, 90 days, and then I broke them, and that way they've absorbed whatever moisture they're going to absorb. And right now it is humid as AF here, 45% humidity in this room right now, so it's humid. Appreciate each and every one. Stick around. Hit that thumbs up if you like these. Hit the subscribe button. That helps the algorithm. Hit the bell icon if you want to see when I drop the next one. Drop a comment down below. Just say hi. Tell me what you want to see next. Suggest materials you want tested, or if you want to see some different kind of test, give me a suggestion. I'm open. I love building these testing machines and then trying them out and figuring them out. So that's it. That's all I got for now. Polymaker, Fiberon line, PET, polyethylene, and then T with a whole bunch of letters behind it. Glass fiber 15% glass fiber. Beautiful semi-matte finish. Got your colors to pick from already. Don't have to wait on other colors to come out. There you go. Next show you're at, ask me for carabiners, because I always have a box of these around. They go fast, but if I have a carabiner and I'm not hanging a water bottle from it, I'll give it to you. Again, can't thank you guys enough for sticking around watching these all the way to the end. And as always, peace out.